Ready?
Hello.
Hi.
Okay, yeah, we are ready.
Perfect. Take it away.
Okay, so hi everyone. My name is Angela, the team lead for Team Fire. And Team Fire has 5 members. Me, Belinda, Nicodemus, Leonard, Brian, and Roy. So I believe they're all in class and you're going to be meeting and interacting with them soon. So today I'm going to be the one presenting. And I think we can start off. Hi, Joy. Can I share my screen?
Yes, you can. Is it shareable?
No.
Try now.
All right.
Are you able to share?
Yes.
Okay, cool.
You can see my screen, right?
Yes, we can.
Okay, so I'm going to start off with the module on databases, which is Introduction to Databases. And first we have data. Data refers to raw facts or figures that can be compressed to produce information. Examples are names, numbers, or measurements. So data is the basic input used to generate information. And then we have database. A database is an organized collection of related data stored electronically for easy access, management, and updating. An example is a student record system with names, IDs, and grades. So in a database, data can also appear in other formats such as figures, graphs, images, and audio-video recordings. A database stores and organizes data efficiently. Components of a database are data models, schema, and small scale or distributed. Data models. A data model defines how data is structured, stored, and related within a database. It provides a framework for organizing and describing data relationships.
Excuse me, could you please go nini pole pole?
Oh, okay.
Ya sana.
Okay, so we all understand data. Hapo tuko sawa. And then we have a database, as I've said, a collection of related data. We're good there. A database stores information. So it can be stored in various ways. That is figures, graphs, images, audio, video recordings. So that's what a database is. Okay. So now I can move on to data models. So a data model defines how data is structured, stored, and related within a database. It provides a framework for organizing and describing data relationships. So this is just data models explains how you organize data, all right? So the various data models are relational, semi-structured, entity relationship, and object-based. So for this module, we are only focusing on but you get to know that there are other 3 types: semi-structured, entity relationship, and object-based. We are good there. I'm not going so fast, right? Okay, schema. A database schema describes the organization of data in a database. It contains the definition of tables, columns, constraints, and other elements identified in the database data model. Examples of elements defined in a schema. So a schema is just the structure, that explains how data is stored. Okay? So elements in a schema are, number 1, we have tables. Tables represent objects in the data model. So for here, like you see this table right here, this is a table. This code name region, this is one table. And this other one, population capacity code, that's another table. Okay? The other element is columns. Columns represent attributes of objects in a table. So columns, we could say that code here is one column. This is a column. Name is another column. Region is another column of this particular table. Here, population is one column. Capital city is another column. Code is another column. Okay, relationships. Relationships represent the relations that exist between tables. So two tables or three or four could be related. Okay, so the relationship, for example, for these two tables, they can be related because of the code. All right, if we had a name column in this population table, if we had a name column, they could be related by also code and name. Okay, so that's how they are related together. Constraints, the other element of schema is constraints. That is, they represent the rules that affect the types of data or object relationships in the database. So constraints are what govern the relationship, basically. So we could say that a constraint here, so it's basically like a rule, it's just that it's a fancy word. So we could say that for every table, like in this table and this other table, these two tables, this table must have the code and this other table also must have the code for them to be related. That's a rule, that's a constraint, okay? So the elements of a schema are tables, columns, relationships, and constraints. We're good? Okay. Small scale or distributed. So databases can operate on small scale. They might run on one computer and support a single user. Other databases are distributed across multiple systems and locations across companies' network, or they can be cloud-based databases that support millions of users. So small scale, they are just on a small capacity. They run on one computer, single user. Distributed, they are across multiple systems and locations. So they are large, they are Zico everywhere, basically. So that's small scale and distributed, a component of a database. And then we have relational and non-relational databases. So relational is a type of database that we've talked about. And the features, we are going to start with relational. We're going to focus on this column. So relational are stores data in tables with relationships. So tables have rows and columns. So a row can also be called a record. So we know a row. A row is, for example, in this, our table above here, this is a row, which we could also call as a record. This is another row, which is also known as a record. I've already talked about columns. Columns are these, and we can also call them fields. That's what is written here. Tables can have multiple records, which are also known as rows, and fields, which are also known as columns. For relational databases, they have a fixed schema. That is, the structure is fixed. It cannot be changed. Okay? The query language used in relational databases is SQL, that is structured query language. And then we have non-relational databases. We're going to focus on here. Non-relational do not follow, the data model is not based on relational tables. It stores data in a variety of ways. The schema is flexible, that means it can be changed. And the query language is not only SQL, no SQL, okay? So here we have the comparison. So we can say that relational databases, they have tables, but non-relational, they are not based on tables. They are not fixed on that. And then the schema is fixed for relational. For non-relational, it's flexible. Relational uses SQL, non-relational uses no SQL. I believe that's good. That's a summary. And then we have examples of relational databases. That is MySQL, Oracle, Amazon Aurora, and the other one. And then non-relational, we have examples, DynamoDB, MongoDB, and Apache HBase. So relational databases are best for structured data and complex queries. They support transactions and provide data integrity because they have a fixed schema. For non-relational databases, they are unstructured or rapidly changing data. That's what they're used for. and they are good for fraud detection, the Internet of Things, and social networks. So this is a very good comparison that you have to know that the relational databases are these ones: SQL, Oracle, Amazon Aurora, and then the non-relational are DynamoDB, MongoDB. As we've said, relational has structure, so it's good for structured data and complex data because it simplifies the data as it's placed in the tables. So it supports transactions, provides data integrity. Non-relational, we've said it doesn't follow the relational tables, so it's good for unstructured or rapidly changing data. It's good for fraud detection, Internet of Things, social networks. Okay. So in short, relational is structured and SQL based. Non-relational is flexible and scalable. The scalability of non-relational databases is horizontal scalability. Okay. Next we have, I hope you're good. I'm not going fast. I hope you've understood. Next we have database management system. DBMS, in short, is a software or database as a service that provides database functionality. It is used mainly for the following: creating databases, inserting data into a database, storing, retrieving, updating, or deleting data in a database. Variations of DBMSs: single user DBMS applications and multiple user DBMS applications. So example of single user is Microsoft Access. An example of multiple user is Oracle Database and Microsoft SQL Server, MySQL and IBM DB2. So for a database, it needs a system that's going to create it. So that's where the DBMS comes in, where you can interact with the database. Okay, so the DBMS is for creating data, inserting data, storing and retrieving, updating and deleting data. So that's where you access your data basically in the form of tables if you're using the relational database. So now we've said there are different types of DBMSs, that is single user and multiple user. So single user, Microsoft Access; multiple user, Oracle Database, Microsoft SQL Server, MySQL, IBM DB2. Okay, that's just a touch base of what a DBMS is. The primary benefit of database as a service is to avoid the cost of installing and maintaining servers. So traditionally, in database management, a company uses a DBMS in an on-premises data center. The company must invest in hardware and software resources needed to support the DBMS. But with database as a service, the DBMS is in cloud in a virtualized data center. The company needs to pay for only the database related cloud resources that they use. So we've been talking about this frequently, that on premises you have to incur the cost of having the actual resources. So that's what they were using previously with DBMSs. But now with the new cloud infrastructure, DBAS, you can have the DBMS in the cloud and you don't have to incur the cost of the resources. You just pay for what you use. Okay, we're good. Database as a service. DBS is a cloud service model that provides managed databases without the need for users to handle infrastructure setup, maintenance, or scaling. The cloud provider manages tasks like backups, updates, performance, and security, allowing users to focus on building applications. So here we are saying that AWS manages the backups, updates, everything regarding to the system. The users just focus on building the applications. All right. So examples of the database as a service is Amazon Relational Database Service, Amazon RDS. This is a web service that facilitates setting up, operating, and scaling a relational database in the cloud. It provides cost-efficient, resizable capacity for an industry standard relational database and manages common database administration tasks. So Amazon RDS is standard relational database. Okay. Here we have Amazon Aurora. It's a fully managed relational database engine that is compatible with MySQL and that one. Aurora is a part of the managed database service, Amazon RDS. So Aurora is part of RDS and it also uses relational database and is fully managed. That's the key points that you need to take away from that. Amazon DynamoDB is a fully managed NoSQL database service. You can use DynamoDB to create a database table that stores and retrieves any amount of data and serves any level of request traffic. DynamoDB automatically spreads the table's data and traffic over a sufficient number of servers to handle the request capacity that the customer specifies. It can handle the amount of data that is stored while maintaining consistent and fast performance. So Amazon DB is a NoSQL, so it's a non-relational database. Okay, fully managed. Are we good? So database as a service is ready to use fully managed database in the cloud. Okay, and also I'd like to mention types of anomalies. We have insertion anomaly, update anomaly, and deletion anomaly. Insertion anomaly is when you have insufficient data to enter into a table, so it causes the insertion anomaly. Update anomaly is when if you update one record in a table, you have to update all the other related records. Deletion anomaly is where if you delete one record, it results in deletion of the related data. So we are done with introduction to database. If there's something you want me to repeat, please type in the chat. I can repeat. If everything is good, please press the thumbs up. Are we good? Because now I'm going to go to the checkpoint questions. Okay, so we have 3 checkpoint questions. Name components of a database. Oh, thank you, Daniel. Hey guys, are we all in class? Hello, hi. Ama tumebaki break.
Hi.
Class.
Okay, so would you mind answering the name components of a database? Oh, yes, Sandra. Tables, columns, relationships. Yes. Any other? Yes, Felix. Data. Yes, Daniel. Data. Okay, so yeah, components of a database is data, data models, schema, and distributed. Can you see the answers? So that's the components of a database. I didn't see anyone mention small scale and distributed, but it's also a component. Hi, the next question. Which database has a flexible schema? Thanks, Chelsea. Yes. So which database has a flexible schema? Ooh, thank you, Felix. Non-relational. Tony, NoSQL. Patrick, NoSQL. Ooh, yes. Thank you. Yeah, the answer is non-relational, which uses the NoSQL query language. Hi, the other question, which database supports transactions? Which database supports transactions? Thanks, Leonard. Relational. Clinton, yes. Relational. Yes. The answer is relational database. So if you're good, I'd like to go to the next topic because it's just a short introduction of databases and I can see that we are good. So I'm going to continue. The next topic is data interaction and database transaction. Database introduction. We have database interaction. We have roles involved with relational databases. So we have 4 roles: application developer, end user, data analyst, and database administrator. Application developer creates applications that populate and manipulate the data within a database according to the application's functional requirements. End user uses reports that are created from the information within the database. Data analyst collects, cleans, and interprets data within a database system. Database administrator designs, implements, administers, and monitors data in database system, ensures consistency, quality, and security of the database. So the database administrator has full access of the database. He can do all the changes in a database. The application developer, he just creates the applications that manipulate the data. The end user just uses the database for whatever their needs are as their need arises. The data analyst, he collects, cleans, and interprets data. So he analyzes the data basically just to get, maybe for example, visual representation, something of the sort. Each role has different ways of interacting with the database. Direct interaction requires the user to know how to use a structured query language command in a specific database management system. Therefore, roles that have less knowledge of SQL would interact with the database in other ways. So the roles that have less knowledge are, for example, the end user. The end user doesn't know how to use, most don't know how to use the SQL language. So they'll have to interact with the database in a different way. And we're coming to that. Data analysts and database administrators would be able to create and run an SQL command. Because you're an administrator, you need to understand how the database basically talks in other terms. So you need to understand the SQL commands. So database administrator has to know the commands, and data analyst, because he analyzes the data and has to get the data from the database, also has to know the SQL commands. So we have types of database interactions. We have client server and 3-tier web application. So there are 2 types, client server and 3-tier web application. So client server model, the user, so this is where how end users will interact, those people who do not know SQL, how they'll interact with the database. So in client server model, the user can use an application on the client machine to send an SQL command to the server over the network. The database management system interface on the server receives the command, runs it, and returns the result back to the client. Okay, so the user just has an application on the machine. They send an SQL command. So the application is the one that has the SQL command. So the user just types whatever they want and the application sends the SQL command over the server. The DBMS interface receives the command, runs it, and returns the result back to the client. Okay, that's the client server model. So it's just user, application, server, the DBMS interface, and back to the client. Okay, that's client server. Then we have the 3-tier web application. So this is a process, but it involves the application, the web server, the user, and the database. Okay, so 3-tier. The user uses a client computer or device that runs on a web browser. A web page is running in the web browser, captures the user's input, and sends a request to the web server. So in client server, we didn't have a web server, but in 3-tier, we have a web server. Okay, so the user is only interacting with the web server, web browser, I mean, which is connected to the web server. Number 2, the web server gathers information on the web page and forwards the request to the application server. So web server communicates with the application server. Okay, a web application component that is running on the application server receives the request. It contains the SQL commands to access the database to satisfy the request. The component sends the commands to the database server. So the web application is running on the application server. The web server has communicated to the application server, but also the application server has a web application component so that they can communicate. Okay, so it contains the SQL commands to access the data. So the application server is the one that has the commands, and that's what accesses the database. Yeah, and the database is on the database server. All right, so the DBMS that runs on the database server receives and processes the SQL commands. The DBMS returns the result to the application server. So the DBMS, which is on the database server, so we have a database server that has DBMS. It receives the commands and it runs the commands. The web application component on the application server processes the results and returns them to the web. Okay, so I skipped something. The database server has the DBMS. It receives the commands, it processes it, and returns it to the application server. The application server sends it to the web application. So the web application receives the final output. Okay, and that's what the user gets to see. Okay, so the web application component on the application server processes the results and returns them to the web server. The web server formats the results into a web page, and the browser on the client device displays the web information that contains the SQL results to the user. Is it complex, or do I need to simplify further? Please reply. If you want to get a diagrammatic representation, it's in the Canva notes. They have very nice diagrams that can help understand them further. Okay. Haya, so we have embedded SQL in application code. In both interaction models, an application contains the SQL commands that the user requires. An application developer embeds the SQL statements in the application code. 1 minute, guys. I have to pause. Okay, sorry about that, guys. There was a lot of background noise. Okay, so we're in embedded SQL. Embedded SQL in application code. In both interaction model, that is the client server, and application, that 3-tier model, an application contains the SQL commands that the user requires. So there is nowhere that the user has to know the commands. The application already has the SQL commands. An application developer who creates the application embeds SQL statements in the application code so that the application can perform database tasks. An application developer can create an application that users can use to perform database tasks. This way, users don't need to know the details of the database or learn SQL. This approach is used in both the client server and 3-tier web application models. So basically what you're saying here is the client server. You can hear me, right?
Yes, we can.
Yeah.
Okay. So basically what you're saying is that the client server and 3-tier web application both use embedded SQL. So that means the user does not need to know the commands. The commands are already in the application, which the application developer has come up with. Okay? Higher. So now we go to transactions in a database. Transaction is a collection of changes made to a database that must be performed as a unit. A transaction is also called a logical unit of work. In other words, either all of its operations succeeds and the transaction succeeds, or if one or more operations fail, then the entire transaction fails. At the database level, either all the database changes related to the transaction are performed or no change is made to the database at all. It's an all or nothing approach. So a transaction is what we use to perform changes to a database. Okay? So a transaction has only one way to it. It either succeeds or fails. It cannot partially fail, partially succeed. It has to do one of either, and it can't do both, succeed and fail. It has to do one, that is, succeed or fail. That's what that whole explanation is. So the status of a transaction can change as it moves from beginning to end. The statuses are as follows. Number one, we have an active state. So the moment you start a transaction, it goes into active state. What is the active state? In the initial state of every transaction and when the transaction is being run, the status is active. So when you're beginning a transaction, it's in active state. Partially committed. A transaction is in partially committed state when it's completing its final operation. So for example, when you're sending M-Pesa, you're sending money to someone, and the final detail that you have to enter is the PIN, your PIN number. So that's going to be in a partially committed state because you are approaching the end, but it's not yet finished. Okay, so you are just completing your final operation. So you are in a partially committed state. After the partial committed state, we have a failed state. This is when any checks made by the database recovery system fail. So if the databases, we've said that a transaction can only have either a succeed or a fail. So if it fails, the transaction goes into a failed state. Okay? Aborted state. An aborted transaction occurs if the transaction is in the failed state and the database rolls back to its original state before running the transaction. So if it has already failed, it goes into an aborted stage. Okay, because now we've just run the checks, and for a failed state, we've just run the checks, and the database has said it's not a complete transaction, so it has to fail. It is in a failed state. After it's failed, because it can't complete, it's aborted. It's stopped basically, but it's called an aborted state. That's when it's in a failed state and database goes back to original. So that means no changes have occurred in the database, so it's in an aborted state. Once it goes to an aborted state, that transaction ends. So the other way it can work is a committed state. This is when all operations within a transaction have been successfully performed and the transaction is considered committed. So the transaction could go into an active state, partially committed state, and then committed state. If it's complete, if it's successful, those are the three stages it will go through. But if it's failed, it will go into active state, partially committed, failed state, aborted state. Okay, are we good? Without transactions, if two or more requests attempt to change the same data in a database simultaneously, the order and effect of changes are unpredictable. As a result, the database might end up in a corrupted state. So basically what we're saying here is, if I try to remove money from my account and add it to Leonard's account, it could happen if there is no transactions, anything could happen. The database could say I didn't remove money and some money is already added in Leonard's account. But also it could say I've removed a lot of money, not the amount of money that I specified. So say, for example, I wanted to remove 50 shillings. But then the database checks and it removes 100. So that means the database has been corrupted without transactions. If there were no transactions, that is what would happen. It would be chaos. Okay, so transactions provide a mechanism called isolation, which ensures that simultaneous change requests are processed one at a time and do not interfere with each other. So I could remove 50 shillings, and at the same time I could remove 100 shillings. So I could do simultaneous actions at the same time because of the characteristic of isolation which the transactions offer. So isolation ensures simultaneous changes or simultaneous actions can be done at the same time. That's isolation. All right, we're good. So properties of transactions. Properties of transactions, they are called ACID. These are the letters that are in bold right here: A, C, I, and D. ACID. If you want to remember them, you just say ACID. So A stands for atomicity. This ensures that changes are successfully completed all at once or not at all. So as I said, the transaction is either successful or failed. So that's what we call atomicity. It can only be one or the other, atomicity, okay? We have C, consistency. Ensures that any changes will not violate the integrity of the database, including any constraints. So if you've said it's removing 50 shillings, 50 is what is going to be removed. So that's what is consistency. Also, if you've removed 50, only 50 can be added to the other account. Yeah, so that's what we call consistency. Any changes will not violate integrity. Okay. I is for isolation, keeps all transactions in isolation. That's what we've talked about above. Transactions are isolated so that they do not interfere with other transactions. So you can perform simultaneous tasks at the same time. That is isolation. Durability, D. It ensures that as soon as the transaction is committed, the change is permanent. As soon as you've entered that pin and left, that transaction is permanent. Okay, it cannot change, it's fixed. All right, so those are the properties of transactions. That is ACID: atomicity, consistency, isolation, durability. So are we good? Because now I have finished that topic of database interactions and database transactions. I'm about to go to the checkpoint questions. Is there anything you'd like me to repeat? We are all good. Okay, so the checkpoint questions. What roles are mentioned in this module that interact with databases? What roles are mentioned in this module to interact with databases? Yes, thank you, Amy. Very good. So answers, guys. Ooh, Gideon, database administrator. Justin, data analyst. Sandra, app developer. Yes, very good answers. Anyone else? Okay. So we have end users, data analysts, database administrators, and application developers. Haya, what are two models for database interaction? The models for database interaction. The two models. Yes, Gideon, client, it's client server. Thank you, Gideon. Felix, client server. Clinton, client server. Ivy, client server. What about the other one? Thank you, guys. Thank you, guys. Yes, Clinton, 3-tier model. Thank you. Yeah, so we have the client model and client-server model, and 3-tier web application model. Okay, so these are going to be tough questions, the next two. But thank you, Alphas, 3-tier model. But if you've understood the context, I believe you'll get the answer. So a bank transfer involves deducting money from one account and adding it to another. If the process fails after deduction but before addition, the database must ensure that no partial transaction occurs. Which property of database transaction ensures this? So it's a property of database transactions, one of the acids. So which is it? To ensure no partial transaction occurs. Ooh, thanks, Justin. A, what is A? Atomicity. Thank you, Gideon. Felix, atomicity. Thank you. Yes, so the answer is atomicity. Atomicity ensures that it's one or nothing. One or nothing. That means it's either failed or complete, successful. And the other question, two users try to book the same airline seat at the same time. The database ensures that each transaction is processed separately, so no conflicts occur. Which property of database transaction guarantees this? That each transaction is processed separately, no conflicts occur. Which is it? Sandra, thank you. Isolation. Felix, isolation. Clinton, isolation. Alphas, isolation. Justin, isolation. Gideon, isolation. Yes, thank you, guys. The answer is isolation. So that comes to the end of my presentation for the two topics. And yeah, I think I'm going to hand it over to one of my team members, that is Leonard. Thank you, guys.
Oh, yes. Good job, Angela. Yes. Can you hear me?
Yes, we can hear you.
Nice. So the next topic that I'm going to talk about is creating tables and understanding different.
Hi Leonard.
Yes.
Kindly, I don't know, add the volume to your mic. You're a bit low on the volume.
Awesome. Okay. Sasa volume iko sawa?
Iko better.
Okay. Nice. So like I was saying, I'm going to talk about creating tables and understanding different data types. Okay. Know how to share. Combination. Okay. One. Can you see my screen?
Yes, we can.
Awesome. So, first of all, I'm going to talk about relation database and SQL. So, like Angela has talked or has mentioned what relation database is. A simple explanation is just think of it like an organized filing system whereby kila kitu iko connected. Like instead of having like one spreadsheet, kila kitu iko like organized. So I use the real analogy whereby folder moja iko na like employees, whereby inside the employees you have names, the IDs, departments, and then there's a folder that is for departments, department names, locations. So yeah, what else do I need to talk about here? Yeah, so for example, an employee folder John works in department 5. Then the departments tells you like department 5 is marketing and building A. So like you see ziko na link because you had initially defined their properties. Yes. Yes, Patrick.
I'm still really struggling to hear you. Is it possible you go max volume? Just go max on it and then try with C.
Chanione, let me see.
Are you using a headphone or an earpiece?
No, I'm using my computer.
Oh.
Computer micro.
Oh,
Let
if
me
it's a
just
computer
see.
microphone, then it might be the volume.
Let's see how can the settings.
Can you access the microphone settings?
Yeah. I'm already in the settings, but it's maximum volume. Maybe
It's
me
maximum.
don't shout then.
Then shout.
Yeah. Okay, I'll try my best.
Are you sure? Salem is saying that the problem might be with our computer, that we are the ones that are supposed to add volume. Is anybody else hearing Salem clearly? Not Salem, sorry. Hearing Leonard clearly.
Let me see.
Yeah, I can also hear him.
I can.
So
He's audible now. Good. Okay, cool. Please proceed.
Trying to get out. Like kuna part nime enter the audio settings and then I can't go back to the screen sharing option.
Oh, we can see your screen.
Yeah, you can see my screen, but now mimi kwenda kwa hii sharing option ndo sioni.
Oh.
Oops. Messed up kidogo. Yeah, I figure out. Okay. So mnaweza nisikia sahi. Yeah, I'll try my best to be audible enough. So another thing I was going to look at is the anatomy of a table. A simple explanation ilikuwa every like follow strict rules, that is the relation database and SQL. So this strict rules hereby it's like a well organized spreadsheet that never breaks its format, whereby you have columns for consistency, like each column holds one type of information only. For example, only names, column that is only codes. So this is where database are so fast, because like for example kama unataka query something in that specific database, you already have specified like names. So nikisema for example I want to access a certain type of name, and go back to that specific column and say, okay, fetch for me a certain type of user. So yeah, another one for the relation is the rows. For example, one row, your complete record, for example, country, city, or an employee. Another thing is the primary key. That is, how do you identify that type of, for example, user, or it's like a number you're una spare like a specific sort of like an identity to that person or that specific object. Then for foreign key, it's the connection, that is a column that points to another table's primary key. For example, city table has a country code, then you match that country code to a country table by the code. So this creates the relationship in the relation database. So without these rules, you have chaos like duplicate records, broken links, slow searches costing computing time. Because like, for example, in your database, you've identified or you've created that order of he link or these codes, I'm tying it to a different city or a certain type of information. When you're querying that user or a certain type of information, it's easy to like fetch all the information you want. I'll provide examples up later. So what is SQL? SQL is the universal language for talking to databases. So kuna Oracle, MySQL, Progress, they all understand SQL. I mean SQL. Yeah. So we have the DML, data manipulation language. So simple explanation, it's like 90% of the DB work. For example, there is the select command, there is the insert, update, and then the delete. So the select command, it's simply like saying, show me, like, it's only can command, like, for example, show all countries in Asia. So this, you input the select command, and then where do you want to select from? We have a country, then the continent is equals to Asia. So what this line does, inasema, so select for me a country, that is the name, from where, which continent do we want? We want from Asia. So then there is the insert command whereby it adds new, create new rows. And then the example is add a new country, insert into country, the code, the name, then the values noise like XYZ, just a normal random country name. Then yeah, Zealand. So this is the code, and then the name of the country we want to add. And then where are we inserting it into the country? Yes, it's update. You want to change an existing information. So for example, a row, we want to update it. Another thing here is use where, or you'll change everything. So what does this mean? Like, for example, I want to specifically change a certain type of information, or where I want to make that change. So you use where to specifically say, this is what I want to change. Yeah. What else? There is the delete command whereby we remove everything or what we specifically want to do away with. And again, you specify where do you want to delete or to remove the information, or else you just delete everything. I'll provide an example later in another slide. So, for example, delete from what? Customer. And where do you want to delete? Last login, for example, like in this case, I was using like 2020 first month, the first date. So any customer where their last login time equal less than that date, then I'll delete them. So, and then a critical thing is update and delete without where. This one, yeah, it leads to a career ending mistake because, like, for example, unaambia an admin delete the whole database. Bro, like, it's very critical to take note of what you're updating or changing in your database. Yep. Another thing is DDL, data definition language. So what is it? A simple explanation. It changes the structure of your database. That is the blueprint or the content. I mean, not the content. So, and again, use it carefully because these changes can take hours in large tables. The three main commands I noted, that is the create the alter, and then the drop commands. So if you create, basically you're just creating new tables from scratch. So for example, every app hivi inasema choose data types carefully now. Right. Yeah, because for example, kama unataka you're handling a very complex database or data system, you need to carefully note or name your tables or information kwa database yako to avoid sort of like confusion, because if you maybe later on you're starting to query the database or updating, unafaa ukuwe like understand a certain tables holds a certain type of information. If maybe you forgot or you misplace or you misname the information of your database, itakuwa very expensive in terms of time, in terms of also like resources. Utakuwa unaanza kuangalia the whole database, like what is defining what. So this is a simple example of how to create a table. That is, you're naming the table as customer, then you are ID, whereby the ID name to that customer you want to add or insert the information. It's an integer, which is a primary key. Then the name, and it's a variable character. How many characters do you want? And then during that, yeah, this explanation also, I think I will create another file. I'll show you briefly later. So another alter is you just renovate. By renovation, that means you either add, modify, or remove columns. Small tables, yeah, simple. What about any con a lot of information? Same thing I was saying to you, like if you name your database, like you structure it very well, itakuwa easier to identify what led to what or connected to what. Another simple command of it's alter table. What table are we altering? The customer. So for example, nilikuwa nimesema, maybe ningesema instead of customer ningesema custom, some other name. Ningeanza kufikiria, okay, what was custom meaning like? So you understand what I'm saying? Like, yeah, naming your tables it's very easier to change or make adjustments. And then add column. What do I want to alter? The column font. Yes. Yeah. Let's continue. So like another command is the drop command, whereby I want to demolish these terms nikiziona, the drop and delete nakumbuka, like yeah, some things happen. So like for example, in the drop command, what are you trying to do? You're deleting the entire table, like eliminate permanently. So hakuna no recovery or no undo that can retrieve or retrace back your action. So again, be careful with these commands. Like, yeah, you nikisema, for example, I'm dropping a table of all customers. So which means this table, all information, like I'm just deleting it permanently. So yeah, again, hapa nilisema like for planning is equals to alter commands during business hours equals to system that downtime, lost revenue. Again, like plan your data types right the first time. You like it eases your future adjustment, future deletion, like a lot of things in the future. Itakuwa easier when you have all these things sorted out well. Yeah, another thing we are going to talk about is the DCL. By the are we together? Or there is something else to note? Cool. Let's continue. So DCL is data control language. A simple explanation is it controls what can you who can do what in your database. So it's like security system, and it can, yeah, basically save billions in breach costs, because this is where, like, for example, people really want to enter systems and sort of like manipulate your database of your system. So if you handle or carefully secure your infrastructure, that is the database system, using these types of commands, like, not only millions, but also like security breaches. Hata mwingine nakumbuka ni the name of the company. Juu kama mi siwezi trust your company with my data, then you lose trust also. So yeah, then one command is we have grant, we have revoke access. So this to what is grant? So it's basically like you're giving access to who can maybe do something in your system. So you hand out specific permissions. For example, marketing can read and add customers, but do not cannot delete. Yeah, simple command here, grant, select, insert on cells to analyst team. Good. We have the revoke command or revoke command actually. So it takes away access. So it removes permissions where no longer needed. For example, contractors, projects ended. So you just technically remove access to that person or that, or maybe a specific, contractor in this example. So the principle, like we've been told by our previous instructor, you provide the least privilege, whereby you give people only what they need. Analysts read data, they do not delete tables, developers testing in development mode, not production. What else? What was I saying here? Okay, so pick the right data box. So for simple explanation, you choose the right data type is like picking the right container. Use a shipping container for pencil and just money. This is like other examples I was trying to understand about these types of commands and commands basically in terms of DB handling. So yeah, I think that's it. Let me see what else I had to go to. See on a chart. Let me see the chart. Let's see. Good. Let's see. There was a I had created a database whereby I was trying to test some of the functionalities of the commands. Let me see if this was the one. It was this one. So I was trying to see like use case of what can I do with these commands. For example, here we were talking about tables and data types. So now let's go to the example. So four common data types. You have the int command, that is the integers. So what does it do? It stores whole numbers, no decimal. Example, this one. What is the use case? So we have IDs, counts, quantities, years, like those values that only require whole numbers. That's why we use integer. Then you have character, so fixed length character. So what does it do? It stores text with exact length. For example, USA, that's the United States, America. Use case again. I think this is easier to understand. Let me go through it. So for example, country codes, always 3 letters. So zip codes. So what else do I need to talk about here? Float also. I think we had covered it in the Python programming, whereby float on decimal numbers. So kama hii pi like 3.14 use for scientific calculation, do not use for money. Like for example, kama nitongaje, juu kama specify a certain decimal number, huwezi tie to like for money because of the rounding errors. Yeah, you like kama hii iko na 3.1415. Yeah, so What else do I need to talk about? Date time, date and time combined. So this an example that I use in relation to the date and time. So what is the use timestamps? I'm rushing to go to the example part. So why data types matter? Storage efficiency. Like for example, ka venye nilisema initially, it's very efficient for you to categorically specify what am I describing in my table, like data yangu inafaa istone in, or how am I structuring my data for easier. One thing is access, for easier querying, for easier like a lot of things. If you not store your data on how they handle properly, itakuwa very not hard, but it will take a lot of time when you have maybe you need to update, you need to handle different systems. So yeah, what else do I need to talk about? Performance. So for example, car database optimizes based on the type. Another thing is data integrity, preventing wrong data. That is, you cannot put text in the integer column. So one example I was trying to show is this one. So you have a clinic database example. So from appointments table, you have appointment date, then date, just the date, and then start time, in just the time, then created that the date time. So ukiona there is a difference. So date time ikona like a lot of information which do I have that example? I don't know, can konayo. But yeah, another thing ni hii ni table ya create ya appointments table which had this type of information. So and then from the patient's table, the patient ID, which here we say is having only all numbers. So to just identify who is this type of patient. So blood group, characters, 2 to 3, like yeah. So this is just the random type of information in my data type. Identifiers. So hapa hivi identifiers nilikuwa naisema are the names you create. So in terms of tables, columns, was the keywords like create, select. So good practice is keywords, uppercase, identifiers, then the lowercase. So an example that is example the create table, then city. So hapa hivi inconsistent capitalization juu. And again, when you nilisema, it's easier for you now to query certain type of information from hata maybe when you are reviewing your code base or your data structure. I mean, yeah, exactly. So if, for example, nikikuja kwa this type of query, it's okay, it's easier. Unaweza query this way, but sasa ina lead to inconsistency in terms of how do I identify what is a primary objective, what do I mean by table ama city? Is it a data type I'm creating? Is it something that is what else do I need to talk about? Yeah, like I was saying, like let me create table city. So hapo hivi nisha identify city is something I want to, it's a table I want to create, yeah. Then ikikuja kwa integer, yes, what else do I need to say? Yeah, so city up I mean the table name, then the ID name, country code, district. These are the column names, identifiers. So from this type of example, it's easier for me now to identify what means what. What did I mean by when I say ID, by name, by city, by district? Yeah, what else we need to talk about? Database differences. So IBM automatically convert identifiers to uppercase. To keep your case, that is, use all codes. Yeah. So this is something I was trying to understand about MySQL, then Microsoft SQL Server. Now the example I was using here, some constraints on data. Yeah, let's talk about here, baby, kidogo. So main point, the constraints are rules that control what data can be entered into columns. So what it does, the not null, the function, the not null command, it forces a value to be provided, that is no blanks allowed. Yeah, so an example is patient ID not null. So the first name, the patient ID, you must have a value. Umeona, maybe for example, a simple example in when you're filling a form, unakuwa so when you're filling a form, you need maybe to specify your email address, your full name, your second name. So these are the type of things that zina specify. I don't want you to provide an empty information into that pale yenye nataka you provide it for me. So the not null function does that. You must provide information into that specific what I want you to provide it for me. So used when information is absolutely required, like I was explaining. Then you need what it does. Every value in the column must be different, no duplicates. Yeah. So license number, no two doctors with the same license, email var, no two doctors with the same email used when, yeah, so this type of things, default, what it does, it provides automatic value if none given. So for example, yeah, kama I created that is the date time, default current time stamp. So maybe what I mean is, for example, haujasema maybe this table that is appointments really create at a certain time. So it autofills the exact time we create automatically that table. And then the status default naiweka schedule. So kama hapo hivi niliweka, I was trying to see like so many appointments. I want to slot an appointment to a patient ama to a doctor. So initially, kama huja specify either you're available ama you're not available, so nasema already uko schedule. Yeah, these are other examples of ADB, create table user. Yeah, the same thing I was talking about, but in more examples. Why constraints matter. So data integrity, again, it prevents bad data from entering, ensures that business rules are enforced, and then database guards against mistakes. So up the same thing as like it's very, very time saving if you really specify what you want to do with the data, so that in the future, if you want to do updates, querying, itakuwa easier to handle your database. Yeah. What else do I need to talk about? Primary. Oh yeah, let's talk about primary key. So primary key is a combination. Let's see, combination of not null and unique. So identifies the role uniquely, automatically. So it creates an index for fast searching. For example, kama patient ID and mteja primary key. So same as what am I talking about here? Let me see if I define it. Is there any other question? Am I too fast, too slow? Check something. You're good, you're good, you're good. Talk about the reserved terms and keywords. So these are the special words that SQL uses. Nika the likes of, what was the key term? Python. Okay. For example, kama in the likes of Python language, uko na else statement, uko na likes of false ama none, true. So you avoid confusing those key terms in what you're defining as maybe your tables, your, yeah, for example, tables. So in this case, kuna the keywords that are used in SQL, kama create, select, insert, update, delete, table, database. So these examples are key terms ama keywords SQL. Then the symbol, special characters with meaning. So hash ni comment in some database. The semicolon is a statement terminator, and then full colon is a parameter maker at variable prefix. Yeah, Python, we'll see more examples about that. For example, trying to see kama hii, create table database, yeah? So this is the table that we want to create, but using reserved words names, yeah? So, let's continue. So the problem that, for example, with not using the correct naming system, your database get confused, and then you have syntax errors, then hard to debug, requires special quoting. These are the, again, venye nilisema, like, or what I had said initially, correct naming of your database, like it will really save you a lot of time, a lot of like debugging, a lot of resources basically. What else do I need to talk about anyway? Common reserved words to avoid. Table names, do not use user. This is a lot of information I try to show to you. That's what I need to talk about. Yeah, let's just continue. See the time, 12:21. Okay, let me try to go faster. So let's go to naming tables. Choose clear, consistent. Again, the same thing I was trying to say. Names that it will be easier for you to query or to identify future when you are now starting to deal with information fetching ama kitu ka hiyo. So for example, here an example I was trying to use is create table patient records. Yeah, this type of names, yeah. But then maybe these are valid names whereby if I try to now link between patient records to, for example, a department or to doctors, it will be easier for me because I already defined clearly what I want to do with the patient records, that is the lab test results. Another thing is the create table. Like if I maybe wrongly name, this will return me an error because of the spacing. Then the has hyphen. So these are the invalid names I was trying to counter check with what I have here, that is the valid names. And then organization convention. So maybe your company also may have like standards. So same like this example is the prefix, the department, you have HR employees, then sales orders. So these also you need to understand what does your company require in terms of the naming system of your database. So that is also something you need to check on. Also clarity. Names should explain what's inside. Yeah. So for example, this one, same like create table T1. What does T1 even mean? But if I come here and say patient appointments, already I understand, okay, in this table, I have patient appointments. Yeah, this is also something I was trying to show. Too short, it's not clear. What does even apt mean? Yeah, maybe you mean appointment, like in this case, but not everyone or a new user can't understand what APT means. PAT also, doc. Yeah, doc can mean a document. Yeah, again, also be consistent, singular versus plural. Choose one style and stick with it. Again, also, if you're going with patience, then let's go with patient. If you're going with a patient, then also I did specify what does even patient mean. Both are fine. Just be consistent. Compound names, pick a format, Kamal casing, as you can see, patient then records, snake case, recommended. So this is just additional information in terms of database and data types naming. What else do I need to talk about? Clinical data. Yeah, this is just the example in the corner I try to use. And then the create table statement. So like here, this is just a basic syntax. What does it say? Creating the table, and I think it meshasema. A simple example, create table that is with the name CT ID. That's not now. That means I require this identity name, default must can be null. So by here, namaanisha like it's not a must for it to be specified. Yeah. Then country code, it's not null. That means lazima uweke district. Yeah, what it creates. Yeah. So for example, this is the command. Then what does it create? It creates a column with ID, name, country code, and the district. Then the type is an integer here, like we've said. Constraints, not null default. Yeah, so this is just basically from this, then you come to this. Then the visual is results. You have the ID, the name, country code, and the district. No data yet because I had basically hakuna kitu inserted there. Nothing I have inserted there. Then if not exist, so yeah, if not exist clause. So the problem creating a table that already exists is equals to error. So in this example, listen, like if city already exists, it will return an error. So the solution is add an if not exists. So create a table if not exists. So what this does, it says go back to my database and check, is there a table with the name city? If it's there, then create for me a city. So it's an explanation. So the table doesn't exist. Okay, fine, create it. If table already exists, do nothing. So that is no error. Used when running scripts, that is multiple time deployment, automations, shared development environments. So this is an example. So create table if not exists patients. So yeah, so this is a table by the name that I named patients. So let's break it down. So if I'm creating the table, and if not exists, self creation, patient ID. So is what I think we've already specified. I was just highlighting the if not exist clause. Understanding the results. So after running the create table, structure exists. This is just an explanation of what I'm trying to explain here. Yeah, let's go to the columns. So the main point, each column in a table has a specific data type and optional constraints. So again, let's say an example, create table, the column name, data type. Yeah, this is just a let's just see the explanation. So the column name, let me see. Okay. Nice. So for example, up in the table, I'm creating a table, the name patients, yeah. But inside the table, I need to have like columns or sections where what do I want the patients in the table to have. So we'll have the patient ID, the first name, the middle name, the blood group, registration date, with what do I want even to acquire from this type of columns. So this is the explanation, yeah. So the column names that I have, patient ID, for example, nikisema like this bad column name, for example, first name. What does it even mean by when I say first name or first name? It's not even, what is it? That I'm trying to remember. Universal identity, like it's not even correct to write this first name in this format, has hyphen. So these are types of bad column names I was trying to show or note down. Yeah, so we have the data type required. Yes, so determines what kind of data do I want inside my columns or inside my tables. So for example, here it's integer. I want whole numbers. If it's variable characters, these are text up to different, like, different characters that I want to be defined in my information. So we have the date, also date time. So these are different types of data which I want to create in my table. Then we have the length parameter. Sometimes require, this is a lot of information I was trying to note down. Just go by not null. I think we had already talked about it. Default also mentioned it. Separating column definitions. So use commas between columns, not after the last one. So what I mean, cool. So for example, in this case, column integer. So this is a column 1, then column 2, column 3. So I am separating the column definition using commas. Common errors I was trying to say, extra comma after the last comma, it will cause an error. Clinic database column examples. So these are just examples I was trying to also create and test what they even mean. So again, this is a lot of information. Yeah, IDs, not some things I think we've already discussed. Nice. Let's go to now the primary keys and the foreign keys. So the main point here, primary keys uniquely identify rows. Foreign keys now create relationship between the tables. Now, for example, the primary key, the definition, it's a column. A column or combination of column has uniquely that uniquely identifies each row. So the rules, they must be unique. Like you can't say, for example, people have the same email. It will lead to confusion, but I want to specifically identify, for example, user A to user B. What do I use? I use a primary key to now identify this user A and this other user B. Yeah, they must be unique. So no two rows can have the same primary key. They must be not null, that is, they can't be empty. And then one per table. Table can have only one primary key, so they must be immutable, that it should never change once set. Yeah, this is just the rules I was trying to show also about the primary key. So let's say a simple example here. Create a table by the name patients. Yeah. So the patient ID, this is the column, the first name column, the last name column. So this uniquely identifies each patient. Each time I'm recording information about a patient, I've already identified or stipulated a unique key that will tie them to a certain patient. So a result, let's take an example. Patient 1, that is the patient ID. What is the first name? John. Last name, Smith. So this is a unique ID to John Smith. Yes. And again, Jane Doe, unique ID number 2, that way. So why is it important? Fast searching. So database creates automatic index. Yeah. So again, when I want to query a certain user, I will just use that type of information for faster querying, faster searching. So also it guarantees you can find any specific row. If, for example, hapa hivi nilisema 120 ama nilisema 210 or a certain different random patient ID, when I'm starting to query them, I will definitely know that if I say I'm searching number 120, it will return me John Smith. It will not return to me, Jendor, Bob Johnson, or any other person. It is specifically to that user. We go.
Leonard,
Yes.
just a sec. Just give me just a second. Samuel, is Samuel in class? Samuel Gitau. Samuel Gitau ako class. Just a sec. Samuel. So Samuel, you're not in class, eh? Is Samuel in class? Now, these are the things that we keep telling you guys, that people should not be joining with their devices. Now see. So, Samuel, because you are not responding, let me just remove you. Yeah, let me remove you. Please don't join class with devices. Don't just join class with devices and then you don't respond when you are being asked. When you are being asked to talk. So Samuel, if you can hear me, I'm removing you. Please call Esther before you get back to class. He has been removed. Okay, so proceed, Leonard.
Oh, okay. Join class, guys. Yes. Can continue now. Where was I? Yes, yeah. Remember now that. So we can continue. So single column primary key, that is the most common type of primary key identification. So what if we have now compound primary key, that is we have like multiple columns. So how are we going to go about it? So we create a table that is doctor specialties. And then we have our doctor ID, specialty ID, then the primary key. Nice. So now, instead of like identify maybe only one doctor ID, we have a doctor here who has maybe, we have their ID and also what is the special, how am I going to define it? Like what is the specialty? Yeah, yes, that one. So now we identify the doctor and their specialty by combining their identification and also, yes, so combination is unique. So anytime I want to, let's see this example. So we have a doctor ID and we have a specialty ID. So that is one. So Dr. 1 with specialty 1, that is a unique combination. Then Dr. 1 with specialty 2, that is also and uniquely identifying them based on who they are and also what they do. So here you can't have one again. That is, for example, if I say Dr. 1 has specialty ID 1, then here again I say Dr. 1 has specialty ID 1. That can't work because already I had said this is a Dr. 1 which has this type of specialty. Yes, that is a combination, a compound primary key. So let's talk about foreign key. So it's a column that contains the primary key value from another table, creating a relationship. What's the purpose? Links two tables together. Let's see an example. So country table, that is create a table by the name country. We have the code, we have the name. So this is their primary key, right? And then create a table that is the child, whereby the table, it's a city by the name, yeah, identity, name, country code, yeah. So come here and say this is a foreign key pointing to the country code, right? So now the foreign key, I'll come and say this is the country code, that's the foreign key. referencing to the country. What is the country? What am I referring to? The name code, or I'm identifying, or I'm linking the country and the city. Yes, so the visual relationship now, what does it mean? So the code and the name, let's say USA. USA is the code, the name is the United States. Then the city table, I'm saying one is the New York, and then two is the Toronto, three Boston, like that. So foreign key now links to the primary key. So this one, that is the number one, links New York to USA. Then Toronto, number two, links to Canada. Yes. Yeah. Wow. There's a lot. Are we really together? Yeah, I'm trying to explain it so that we can take questions or something. So key points, country code in city table is equals to the foreign key. To must match a code value in a country table, like what I was trying to say here. It's great. It creates a parent-child relationship whereby the parent is the country and then the child is the city. So country is equals to, yeah, like what I've said. So let's take another example of a clinical database. Primary key and then the foreign key with the examples. So example one, I have a patient and a person. So I'm creating a table by the name person, then person ID, first name, last name, then the parents, patient's child, table, which is the child. And we say, let's identify patient ID, provide it with the primary key, then the person ID, which is this one, I'm linking it to the patient. Yeah, so that's a foreign key to the person's table. Yes, good. So foreign key now is that we have the person ID referencing it to the person. So this is the ID, the key, and then I'm referencing it to the person, which is the person ID. Another example, we have the appointments. So same thing. So appointments is the table, have the appointment ID, the primary key, and then patient, this type of information. Then I'm saying foreign key is the primary patient ID. And then I'm referencing it to patients, tying it to the patient ID. So does it mean one appointment belongs to one patient, and then one appointment belongs to one doctor? Yeah, the second foreign key. And then the third one appointment belongs to one department. Yeah, so I'm linking all this using the multiple foreign keys. So rules for foreign keys. Foreign key value must exist in the parent table. As you can see, I already have a patient ID. So I can't say I'm linking a patient ID which doesn't exist. First of all, it must exist first so that I can link
Leonard,
it to...
Leonard, a minute.
Yes.
Kindly, Salem. Salem, call me. Get out of class and call me, Salem. Okay, thank you, Leonard.
All right. So again, we have also rules for foreign keys. This one we've already said, the foreign key value must exist in the parent table, like not to be null if allowed, or be null if allowed. So we can say, like I was saying, this is not null. So that means it must exist. So if I say default is equals to null, by that I mean, okay, it's not a must for it to be in existence. But the point is you must link with something that already exists. So cannot delete the parent if children exist unless using cascade. This is another command or another clause which maybe I can be able to talk about later. So you can't delete a parent if children already exist. So for example here, I'm linking all these to the patient ID here initially. So I can't delete the parent if already I have the children. Where is another example like here? So I have the patient, which is a child. So I can't delete the parent, which is which one? The person, if already I have the children, that is the patient ID and the person there. Yeah, those are the keys that I'm referencing to. Is it person, not patient? Yes. What else do I need to talk about? So example of a foreign key detection. So this will fail. So like I was trying to see. So delete from country where code is equals to USA. The error is cannot delete because city's reference is equals to USA. So must delete cities first, then the country. So here you say delete from city where the country code is equals to USA. You delete the children first, which what is the children? The city. Then the parent is the USA. Delete from country where code is equals to USA, then delete the parent. Like I was trying to say here, you cannot delete parent if children exist. So yes, this is the detail or further explanation of what I was saying. Referential integrity, main point. So referential integrity ensures that foreign key values always match existing primary key values or none. Same thing I was trying to explain. So what is a referential integrity? A database rule that ensures relationship between tables. Oops. Relationship between tables remain valid. So simple rule, every foreign key must, a value must match a real primary key. Again, what I had already said. So this is just the further explanation of what I was trying to say. So all foreign keys, that's the country code, match primary keys, that is the code. So yes, do I need to explain? So this is no. I need to explain what referential integrity prevents. One, orphan records. Yeah. So you cannot have a child without a parent. You can't have a child without a parent. Yes, that is what I was trying to refer to. So could insert seat without a with non-existent country. So insert into country, so XYZ doesn't exist in the country table. That is an orphan record. So I think this is a further explanation of what I was already explaining earlier. Then problem 2, we have a breaking relationship. So without referential integrity, again, ID points to nothing. So for example, I delete from country where code is equals to IND. Now Mumbai country code is equal to IND. So I'm not referring anything, or I haven't determined. So delete from country where code is cannot delete parent row. Child rows still reference this country. Still further explanation how to maintain. I think this is really much more explanation. Are we really together? Because this is much more like what I am continue to explain about primary key, foreign key. Yeah, let me see what's remaining in the LMS. Let me see. Oh, just chat saying okay. Let's go back to the LMS, see what is remaining. Any other question as I'm going back to the LMS? See key takeaways. Oh, and by the way, this explanation about the patients and the clinics, yeah, it is a database I had created earlier. So I can also provide a link for you to go further and see what is it about. Can you see the LMS first of all? Yeah, see what we are remaining with. 2. I think we've talked about DDL, talked about DCL, work grant, basic SQL elements. So you have the int, character, float, date, time. I think we've talked about that. Have the identifiers that represent the names of the object that the user creates. Yes, we've talked about this one. It's important to remember IBM, Oracle. So when you're processing code that you write, IBM and Oracle automatically converts identifiers to uppercase. And that is, they will ignore the case that you use. I think this is other detail you can read on. Not null, we talked about it. The unique, the default, reserved key terms. We've talked about this one. We've talked about tables, naming tables, why you need to have or be careful on what you provide or name your table. What else? Creating table statements. Yeah, this we've talked about. If not exist, the columns, really talked about them. Primary key, foreign keys. I think we are good. Our referential integrity. Maybe I can go talk about it a little bit more. The group table statement. Yeah, I think maybe this is not what I've talked about. Character string. Okay. I think we can continue from here. So the character string is a data type. This data type is described by a character. That is, for example, length. This data type is used. I think we had talked about this in Python. So this data type is a character string with a fixed length. Values for this type must be enclosed in, so it must be enclosed with the quotation marks. Variable varchar. Excuse me. So this data type is a variable length character string and its maximum length is fixed. Character large object. This is a large character string or text data that can have a length in order of gigabytes of GBs. Another explanation. This table consists. I think I had. You can see there's somewhere I had written this one. Can leave you to go and read more on that. This decimal. Let me see. So I had created explanation on them. Yeah, I think I talked about it. See. See. Okay. I think I've provided more on what I need to talk about. Yeah, let's maybe answer this question. So what is the SQL statement that is used to create a table inside a database? Yes. What is it? Who will provide me with the answer to this question? Let me see the chart. I can't see the chart. Yes. So the question is, what is the table? Kidogo tu. Yes. Yeah. Yeah, what is the SQL statement that is used to create a table inside a database? Yes, let's go to the chart, see. See chart. Ah, nice. Gideon, thank you. Create table. Yes, yes, create table. That is column 1, data type. We have Sembi Daniel. Thank you, thank you. Angela, we have to create table. Yes, yes, yes. And also, like, sometimes you need to also identify or understand the correct, what can I say? The correct, the term na tafuta ni caps, yeah, caps. And so like you need to understand, for example, how are you defining your, or how are you writing your statements in the database to avoid confusing or confusion in terms of when you're querying or obtaining like information about your database. It's easy even to proofread and also, but yeah, good job, Juma. Great table. Thank you, Angela, Daniel, Gideon. Yes, correct answers. Thank you for your engagement. What else do I need? The question. Going back, it's not easy. Let's see. Yes, I have to go back again. Come to sharing again. Experience. Good. Back again. So what is the purpose of the primary key in a table? The primary key is the one in like, why do I want to, yeah, let me ask the, instead of answering. So what is the purpose of a primary key in a table? To see your responses. Yes, thank you. Thank you, Sembi. Primary key is a unique identifier. So we have uniquely identify each row or record. Yes, 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 yes. Specifically, good job, good job. What else do I want? Wow. For uniquely, Juma is saying for uniquely identifying the table entries. Yes, thank you. Thank you for the response engagements. Patrick, I think you're noting the engagements. Ongeze marks, yeah? Yes. Yenye wako nayo, ongezea. Yeah. Add to them. What else do I need to talk about? I think I've talked about almost anything. Let's go back to the LMS and see. Somebody's laughing. No, honestly, when I come to chat, I'm having a problem going back to the presentation again. So I have to see how I can maneuver that. But I've understood how to move around there. So I think that's all. What were the topics I was going to discuss? There was one about, no, this is not for now, retrieving data, but that was what I was supposed to talk about right now. Yes. I've used a lot of time. Yeah, I've remembered something. I was to share to you about the data that I was using. Is it? Can't remember. That's what really provided me a deep understanding about this database information. Yes.
Okay, so Leonard, I assume you're done? Okay, cool. Thank you. That was some very good presentation. Please let me see some hand claps for that team. We've had the first two of them presenting, that is Angela and Leonard, and more is to come in the afternoon. So they'll be with us in the afternoon. Before we let you guys go, just give me a second. We are supposed to be getting some announcements from Esther. Let me just get her for you guys. You're supposed to be getting an announcement from Esther. Let me just get her. Give me a sec. Okay, so Esther will be joining us shortly for a small announcement.